us or show how to use GDC for geometric sequence. Right, so here we have a nest of ants with 500 individual initially, and the population is increasing by 12% each week. We see here it's increasing by a percentage. So percentage actually involve a multiplication operation. So this is a not addition or subtraction. It means it's not an arithmetic sequence, it is a geometric sequence. If we have a sequence which increase or decrease by percentage, it is a geometric sequence. Okay, so how many ants will be there after 20 weeks? And second one, how many weeks will it take for the ant population to reach 2000? Kind of like when is the first time it reached 2000. Okay, let's see what formula we will use for these two questions. We have un equal u1 times r to the power of n. U1 here is the initial amount of ants in this question, and r is the common ratio. So the common ratio will be the percentage increase. However, we need to change to multiplier. Okay, and n will be the 20 weeks. Will be the time it takes or number of week. Okay, so I'm gonna do add calculator here. So therefore, so we use how many ants? 20 weeks. So we're gonna do 500 multiply with 1.12 to the power of 20. Okay, so we get 4823. Why it's 1.12? Because initial percentage, initial amount will be 100 and it increased by 12%. Okay, so we have 112 and this 112 we divide by 100 to get the multiplier. So it will be 1.12. That's why it's 1.12 here. We remember we always put the multiplier. If it's increased, we add them. If let's say it decreased by 12%, so what should we do? So we should minus them. 100 minus 12, and that 88 we divide by 100. So we will get the multiplier of 0.88 if it is decreased. Okay, so therefore the first answer is, what do we get earlier? 4823. 4823. 4823. Okay, how many weeks will it take for the ant population to reach 2000? How many weeks? So means that we are looking for the n. Yeah, so the initial will be again will be 500. The multiplier will be the same, and we are looking for n and when it will reach 2000. So in this case, we can use n solve. Okay, so we use a menu, algebra, numerical solve. So we can put 500 multiply with 1.12, and we don't know when it is. It will be x we're looking for, but it must be equal to 2000. Okay, and then don't forget to put comma and then x, and this is our x, 12.23 or 12.2. That will be number of weeks. Yeah, and we can also solve this using a graph. So we graph this one function and we graph another line. We look at where it crosses, where it intersects. So let's try to do that method. At graph, so that will be 500 multiply with 1.12, and it will be power x. So we get one graph. Okay, if it's happened not appear like this, let's change the scale. So maybe it's 3000, and here, okay, so it's visible now. Okay, let's see, and we have it's equal to 2000. So this is another function. So let's put one more function, tab, and that will be a horizontal line here, and let's see where it intersect. We can drag them. So where it intersect, we need the intersection here. Okay, let's move this above. Okay, menu, analyze graph, intersection, and we trace them, and they mention here 12.12. So looking for x, 12.12 is the x. And what is this? 2e plus 3, it means 2 times 10 to the power of 3. Okay, it means 2000. Yeah, so the y definitely is 2000. It is the coordinate here. So 2000 can also be written like this, 2e plus 3. This is kind of like a GDC standard form for a graph. Okay, so there are two ways of solving this, either n solve or we graph them.